Hello, this is Clayton Balmas, and I'm your teacher today here in our audio classroom here at SynMax University, available at synmaxperformancelubricants.com. Today, we're going to be talking about metal surface technology improvements, and it's basically how we can have metal surface lubrication technology and apply that to racing or commercial components for performance and durability. We have a saying here at SynMax. It's the aerospace advantage for motorsports, kind of like this picture here. Well, we have a thing here called oil tribology. It is the science of oils and oil chemical materials working in harmony with the surface to which it comes in contact and how it's to perform accordingly. So that's kind of ASTM, Society of Tribologists and Lubrication Engineers, fancy technologies, is saying the science of oil to work to the application. You see, the primary goal that we're trying to achieve is this: provide a hydrodynamic film of protection through viscosity, stability, quality base oils. We want to be able to dissipate the heat from the components, in other words, for them to run cool. We want to decrease the friction, in other words, lower the coefficient of friction, which will then increase the energy output of what we're accomplishing, be that an engine, transmission, or differential. And if this happens, the components will run cooler, the life of the components will increase, and the entire system functions will operate smoother with much greater efficiency. So this applies for racing and also energy efficiency for your everyday automotive and commercial requirements. How do we improve metal surface technology? Well, that's a good question. You see, like a physical body which has a skin with pores that open and close, open when hot and close when cold, so does a metal surface. We have a terminology that we've discovered, and it's really simple. It's called these micron-sized metal pores. We call it like a micron metal sponge. All right. When it's hot, these sprawls in the pores were open, and then during the cold cycles, they'll close. Now, during a break-in or during this, if those pores are not kept cleansed, all right, contaminants and micron particles will be released from the metal surfaces. And this process really should be performed during the initial break-in surface. But on the reverse, the micron metal pores will then absorb whatever additives or contaminants that the mineral technology will be applied with heat and or friction. So in other words, the technology that's inside of the oil will be absorbed to the surface. So if you choose to have low quality metal technology, there you go. If you desire to have a higher quality additive technology to improve the surface, then it's your choice. Like a micron metal sponge, during the heat and cold operation cycles, when the component is hot, the metal expands and the pores are open, as we shared. Then the surface metal pores with a lubrication polarization, that means like a magnet. There's a polarization that happens in there. All right. The nano mineral technology will be received in. That could be ceramic, diamond carbonates, could be boron, could be Teflon, could be moly, could be diamond-like technology such as used at SynMax. It's whatever choice that would be. Now, furthermore, in the oil, if you have a special tackifier package in it, such as what SynMax has and some selected, it will increase the ability. Not only does it crawl when it's cold, but it adheres the additives to the surface much better. on a nano basis. But you see, after the cycle, the metal is cooled and contracts. The pores then closed, and then the improved metal technology, as we stated above, will become one with the surface. And there are specific additives for different metals. Your carbonates will be for steel. Your other additives special for aluminum. Okay. And after a couple of cycle times, hot and cold times, it's just not a magic one-off. Now, moly, that one comes in pretty hot. Your others, they might take a little time. All right. After about 3 hot and cold cycles, the metal surface technology embeds. And furthermore, as it wears off, the additives are still in the oil, and then they continually refresh the metal surface as it goes. All right. See, there's 2 ways to improve the metal surface technology. You can either do it with engineering, which is very costly, getting your tungsten disulfide or boron or cobalt additives put on there, which are very great. These processes include an impingement or coating of the metal surfaces of solid film lubricants and things like this. But you have to understand that it's a whole science. There's a difference between a rolling and a sliding additive. Also, and I believe we're going to get into this, there's a plasticity. When the metal expands and contracts, if the if the coating is harder than the surface that's expanding and contracting, those additives can just break right off and actually be more destructive, floating in the oil or the grease. All right. So please consult with a specialist when it comes into this, what is best for the application. Usually people in the aerospace and military industry have got a pretty good hold on this. Usually in the process applications, the surface have to be prepared and applied, as I said, with aerospace perfection. If the surface isn't cleansed properly in the impingement that comes in, basically it gets fired into the surface, and with heat it's got like a mini welding effect. It's not going to do well. Further, as I shared before, it'll create a harder surface, and it's not always the answer when the metal expands and contracts, and if it doesn't have a plasticity or flexibility with the metal, it's going to create spirals and it's going to go off. So what we're trying to do is to provide a metal surface technology that can go into the pores of the surface of the metal that will coordinate and work with what we call a term synergy at that level. And that's what the Diamond Like Additives are doing. And as the metal expands and contracts with the hot and cold cycles, it will be a pretty good champion to do that. Now the affordable way, as I shared, is with lubrication by using aerospace level additives. Basically with what we call tribology. That's just a fancy word for how the oils interact with the surface to the application. This metal surface technology can be achieved through the additive package selection. Okay, and the fact is that the future is here today. That current advancements in nanotechnology is available right now in 2011 and beyond by using a variable of special material compounds and formulations. These special aerospace additives, such as the Diamond Like Additives available at SynMax, embed and continually reapply upon the metal surfaces, and it takes heat, friction, and operational cycles. And very close, within about 80 to 90%, these aerospace nanotechnology within the oil provides very close to the same results of the applied coatings. So, the Diamond Like additive can work in the rolling and sliding environment. These additives to the specific application can work to the engine, the power steering, the transmission, the differential, for all your bearings. One of the main goals is to get the advanced anti-friction protection technology to continually recycle and re-embed upon the surface during the component life operation. See, this is the advantage with advanced tribology and lubrication in aerospace additives. Remember, you require a specific design lubricant that will work in cooperation with the exact nanotechnology to absorb and embed upon the multiple material surfaces. Now, the lubrication and the base oils you want something that has the best stability possible in the hottest and coldest conditions. That'd be a combination of what we call your PAOs, which is a polyolefin, or POE, which is a polyester. You see, these additives must be of an extreme level of durability to provide continued and long-term performance repeatability. One of the problems, so in other words, you have to have, if you got a really great base oil, aerospace level base oil, you also have to have that equal additive package so the additive package doesn't fail. You see, you get what you pay for. Problem is when you go to great expense and you apply this aerospace coating and then people just use junk oil. See, that's what happens. And this is what happens in your professional racing. It says, well, I got a free pallet of whoever, so make that transmission work with that free pallet of product. When in all reality, if they would have bought a better lubrication engineering, they could probably cut their costs by about a third in aerospace coatings of what they're trying to do. So, SynMax Performance Lubricants, we believe, has the exact formulation with Diamond Like Additives, which has had over 5 years of history and track record for the specific application needs of the engine, the power steering, transmission, and differential, grease, and others. So this is the end of our presentation. So bottom line is this. You can have the ability to have aerospace technology within the oil through the advanced science of tribology, which is the application of the oil to the need to the surface. And if you desire the highest levels of performance repeatability and component durability, all right, have a look at the performance line of SynMax. I think you'll be pleased. So this is Clayton Balmas here with SynMax University, and I want to thank you for our time together, and I look forward to seeing you at our next session. Also, please look at the DLA test presentation. I think that'll show you a lot when you look at the flat tappet test and magnification. So we'll see you at our next session. Bye now.